have mine there. Where's your calculator? Are you okay? You have a calculator. Bring it. This one can set it up. Good evening. Welcome to Chemistry Class. I trust your day has been great. I trust your weekend was pleasant and was productive. I trust you've been taking out time to go through your notes, go through your textbook, and even go through past questions, right? Don't forget that the exam is fast approaching and it's expedient to make good use of our time so that success will be attained. Based on last class, we started this topic, acid, base, and salt. We got a particular junction, which I said we'll continue in today's class, and then we'll be able to solve enough past questions. Okay, so let's just do like just a little recap of what we did last class. Last class, we started with acid, right? We started with acid, and we all know by now that acid would have hydrogen ion, right? And base, which can alkaline will have OH, right? OH group, right? And then we talked about classification. We talked about classification based on their source, right? Which is organic and inorganic. And for organic, that means for plant and animal, and inorganic, they are synthesized in the lab. Organic and inorganic. We also made mention of classification based on ion concentration, right? The solution of it in water. We made mention of based on the solution of it in water, where we talked about strong acid, the solution of acid in water, strong acid, and we talked about weak acid. That means one can dissociate completely in water and the other cannot dissociate completely in water. Weak will not dissociate completely in water, whereas strong will dissociate completely in water. We moved ahead to talk about then their concentration, where we talked about dilute and concentration. Concentrated. That means dilute contains more percentage of water than the acid in the solution, whereas concentration contains more percentage of the acid than the water in aqueous form. Also, solution and aqueous form means the same. Then we talked about their uses, and then we moved on to talk about characteristics. We talked about physical and chemical characteristics. I made mention of one certain thing. I said for acid, it will turn blue litmus paper red. So for acid, blue litmus paper will turn red, whereas for base, red litmus paper will turn blue. Red litmus paper will turn blue. So, and I made mention that if you are then asked what is the color of litmus in acidic medium, it is not blue, rather it is red, because acid usually turn blue litmus paper red. And so when you are asked what's the color of litmus in acidic medium, the answer is red. And when you are asked the color of litmus paper in alkaline, then it is blue, because they basically turn red litmus paper blue, right? We talked about properties as well. We talked about reacting with metal, right? And we also made mention of a particular reaction, which is known as neutralization reaction, and also hydrolysis of salts. All of this recap is so that when we start solving past questions, you'll be able to follow. So neutralization reaction is basically the reaction of acid and base. Reaction of acid, the reaction of acid plus base to give salt plus water. Reaction of acid and base to give salt and water. Whereas hydrolysis of salt is the inverse of neutralization reaction. Then it is salt plus water to give acid and base, right? So for neutralization reaction, the reactant is acid and base. For hydrolysis of salts, from the word hydrolysis, you know we are talking about water reactive. And see, hydrolysis, water, salts, then is just easily relatable. Reaction of salt and water to give acidic and acid and base. And I made mention it can either be acidic or basic. When it is acidic, that means the acid in that is strong. When it is basic, that means it contains a strong base. Before moving ahead, I also made mention of basicity of acid. Basicity of acid. And I said basicity of acid is the number of replaceable hydrogen ion in one molecule of acid. Are you following? Okay, so it's the number of replaceable hydrogen ion in one molecule of acid. Where I mentioned mono, di, right? Right, when it is monobasic, that means you say it contains one replaceable hydrogen ion, and when it is di, it contains two replaceable hydrogen ion in one mole of acid. All right, that's good. Okay, so we moved on to salt itself. We've also salt, from what I wrote down, is the product of neutralization reaction. Salt is a product of neutralization reaction. So when we are asked what is salt, salt is basically the product of neutralization reaction. And so at this point, I didn't talk about this in last class, so I will just start up from that before I move on to pH. Salt, when you are asked to classify salt, salt can be classified based on their solubility. Salt can be classified based on their solubility. It can be classified based on their solubility. So we have soluble salt and we have insoluble salt. So we have soluble salt and insoluble salt. For soluble salt, that's where you get from neutralization reaction. So for soluble salt, the way to get it, one, the neutralization, that's the reaction of acid plus base, which we take as this one is soluble, it's not soluble, but this is what we are interested in. Okay, and so it's also the reaction of acid plus metal and reaction of acid plus carbonate. Charles the carbonate. Let me write it. Let me just write carbonate. Carbonate. So the reaction of this, reaction of acid and base, reaction of acid and metal, reaction of acid and carbonate will give soluble salt. Don't forget, I've established the fact that you can classify salt based on their solubility. We have the soluble salt and the insoluble salt. So they are prepared definitely differently because one is soluble, right, and the other is not soluble. That means, what do I mean by being soluble? That means it can dissolve. I'm sure you were in class when we talked about solubility. If you're not in class when we spoke about solubility, please check the videos on solubility. I'm sure you know where the list of videos are. And so on your group chat, check the list of videos and then you can benefit a lot because we dealt with calculation on that solubility. Moving back, so these are the three ways in which soluble salts can be prepared. So how do we prepare insoluble salts? Insoluble salt is prepared by the decomposition of salts. That's how you thermal decomposition, rather. Or let's just do decomposition. So if you are given a question, let me quickly check up a question on that. Or should we wait? Should we wait? Should we wait? Should we wait? Okay, let me wait. Let me wait. Let me wait. Okay, so soluble salt, we'll come back to the question that addresses this. Okay, so soluble salt, reaction of acid and base, acid and metal, and acid and carbonate. While insoluble salt is by double decomposition, right? Double, okay, let me write double here. Double decomposition. So that is that about that. And in the last class, we talked about pH. pH, which I said is potential of hydrogen. And we talked about pH scale. pH scale is a measured scale, is a numbered scale from 0 to 14. Here being 7. Here acidic, and here alkaline, right? And I said from here, so here will be for strong acid, and somewhere here will be weak, right? Here would be weak, somewhere here will be weak, and somewhere here will be strong. Why? Because 7 is neutral. So strong acid will have values, lower values of pH, will have lower pH values, whereas weak acid will have higher pH values, not up to 7, right? For base, strong base will have values close to 14, right? And weak base will have value close to 7. And what else did we talk about last class? We talked about the formula, pH. And I said pH is the negative logarithm of hydrogen ion concentration to the base of 10. Negative logarithm of hydrogen ion concentration to the base of 10. So POH is also the negative logarithm of hydroxyl ion concentration to the base of 10. And we concluded by saying pH plus POH is equals to 14. pH plus POH is equals to 14. And we took some questions on that. And it was at that point we drew a curtain to it. And so let's pick up from here. Let's pick up from here. And what we're starting off in this class is indicator. Indicator. I'm sure we've heard the word indicator before during our titration class, right? And so indicator is basically weak acid or weak base that show color change based on hydrogen ion concentration in a solution. Let me check that again. Indicators are basically weak organic acid or base that show color change. When we hear the word indicator, that means it indicates something, right? That means it points out something, it sheds light to something, and that is what it is. They are weak acid or weak base that show color change based on hydrogen ion concentration in a solution. So they are usually used during titration in order to know the end point. They are using titration in order to know the end point. I'm very sure everybody in this class that needs to be here would at one point or the other have done titration or is aware, even though you're not done it physically. It was the experiment was performed in front of you, and before they started filling the conical flask, right, with what is in the burette, you would notice 2 drops of a particular chemical was added to it, and you suddenly saw, you might have seen a change, orange change, purple change, depending on what the indicator is, or maybe it might be colorless depending on what the indicator is. And at some point while you're doing the titration, you just suddenly realize a sharp color change or a gradual color change is because of that indicators. And so indicators basically shed light to something. And so they are weak organic base or acid or that show color change based on hydrogen ion concentration in a solution. So that's what indicators are. And so indicators that we should familiarize ourselves with here: methyl orange, litmus paper. I'm sure we all know that. Litmus paper, phenolphthalein, phenolphthalein, methyl orange, litmus paper, and phenolphthalein. So these are the indicators we should familiarize ourselves with. And so this is then the table. This is then the table. I made mention that what indicators do, what they show color change based on hydrogen ion concentration. And so in basic medium, they have a color. In acidic medium, they will then take another color. And so this is methyl orange, litmus paper, and phenolphthalein. In acidic medium, methyl orange has red color. Methyl orange is red. And so in basic medium, it is yellow. For litmus paper, in acidic medium, it is red. We all know the general property we used to say that, oh, acid turns blue, litmus red. And I started with that in this class, that the concluding part of the color is red. And so when you are asked what is color of litmus paper in acidic medium, it's not blue, because the acid will change that blue to red. And so the answer is red. So in acidic medium, litmus paper is red. In basic medium, litmus paper is blue. And then phenolphthalein, in acidic medium, it is colorless. In basic medium, it is pink. Let me take that again. For methyl orange, acidic medium red, basic yellow. Litmus paper, acidic red, basic blue. Phenolphthalein, acidic colorless, basic pink. And so please try to learn this table, because I'm sure there are 3 marks questions. I saw some of them before coming to this class in our table. I think I saw that of methyl orange. If you are able to get there, you will then see the question as well in a particular year. That was the color of methyl orange in, I think I saw, I'm not too sure, but acidic medium. Acidic medium. That was the color of methyl orange in acidic medium. And we're given orange, red, yellow, colorless. Pick one. Definitely the answer is red. Right, so let's now move on to indicators to be used for practicals. I made mention that indicators are used in titration, right? And they show color change based on hydrogen ion concentration in the solution. And so different indicators for different use. That means, we have weak acid, we have weak base, we have strong acid, we have strong base. And so let's just look at this chart. Acid, strong, strong, weak, weak. Base, strong, weak, and then the suitable indicator. So for a titration that involves strong acid and strong base, any indicator can be used. An experiment that involves strong acid and strong base, any indicator can be used. If it involves strong acid and weak base, then methyl orange will be used. If it involves weak acid and strong base, phenolphthalein will be used. When it involves weak base and weak acid, there is no suitable indicator. Let me take that again. For strong acid, strong base, any indicator can be used. For strong acid, weak base, methyl orange. Then for weak acid, strong base, it is phenolphthalein. And so that's just basically the 2 tables that you need to know. And then 2 formulas, basically pH and pH formula, and pH plus pOH equals to 14. This is minus log of hydrogen. That's all. That's basically everything about that. And at this junction, we've come to the end of the theory aspect of this topic, acid, base, and salt. So let's use the remaining minutes we have to consider some questions. Consider some questions. Okay. Okay. Okay, so before I attempt this question, let me just take us back where I mentioned types of salt. I made mention of normal salt, acidic salt, that was the last class. I talked basic salt, double salt, complex salt, and hydrous salt, and then hydrated salt. Hydrated salt has water of crystallization, right? And so this is off. And hydrogen salts do not contain water crystallization. This is off. Complex salts have complex ion, and complex ion are ions. We know ions are charged atoms, right? So complex ion will be group of charged atoms. So it can be A, B, C raised to power minus 2, right? ABC symbolizes elements. Do you understand? So complex salt are salt that contains complex ion. When you notice that the name is just too long and you can figure out like 4 or 5 elements in it, you know that is a complex salt. Not really. It's double salt. But once you see an ion, a complex ion, that means it's in a bracket, and then you see XY, you see something like this, then but this charge will not be there. The charge would have been moved here, right? So a salt that has complex ion is called, the charge will come here now. So this is complex ion. And when it reacts with XY, you know this charge will come here. Whatever charge that XY, if XY has 3, so it will be ABC3. The charge will switch. It's just like calcium and OH minus. If you want to react it, it will be CaOH2. This charge will come to the anion, this charge will come here. You understand? So that's about that. So complex salts will have complex ion. Double salt, long chains. That means you're seeing 4, 5 names there. That means it's a long name, right? They are usually made of multiple atoms. So this is gone. Normal salts are your regular salts, right? Product of neutralization reaction. The acid and the base completely ionized, and then you get your normal salt like NaCl, like Na2SO4. These are um these are normal salts. And then for acidic and basic, that's what I want to dwell on. Acidic salt would always have hydrogen. Basic salt will always have OH in the middle. So for acidic salt, it might be Na. You know, this is Na2SO4, NaHSO4. That means all of the replaceable hydrogen have not been replaced, right? And so for OH2, all of the OH has not been replaced. Basically, when you see a salt and you can see OH in it, you know this is a basic salt. When you see H in it, you know it is acid salt. And when you don't see anything and it's just a moderate salt, yes, this double long complex ion. And I just come here to hydrated as water of crystallization. Okay, so in the light of that, let me then attempt this question. Okay, which of the following, sorry for my abbreviation, so that we can move on. Salts will dissolve in water to give a solution. This is solution, this is water, this is following, this is the, I'm sure you're familiar with all of this. Less than 7. A, HKSO4. B, ZnOHCl. C, Na2CO3. D, NaCl. Okay. table is not. It's not. Sorry. Apologize about that. Please let's learn this today. Please let's take time to study it. I was considering a question. Okay, yes. The type of salt that ionizes to produce three different ions in solution is A acidic, B complex, C double, D basic. Let's take the question again. The type of salt that ionizes to produce three different ions in solution is acidic, complex, double, basic. We know it doesn't fall under basic, right? It doesn't fall under acidic. It doesn't fall under acidic, it doesn't fall under basic. We're left with complex and double. I told you for complex salts will have complex ion, whereas double will have long chain, it will have so many names. And so because it contains different ion. And so when you start to count it and you're seeing 3, 4 elements you can pinpoint out of it, then you know that it is double because it ionizes to produce 3 different ions. It ionizes to produce 3 different ions in solution. So our answer is basically double salts usually have long chain, right? Because they contain multiple alkyl ions. They contain because they can dissociate to form different ions. Right, so that's why I said when you see it, you see that it has a very long name. You know that it's double. When you are seeing an ion, that means 3 elements is in a bracket. Then you know that it's complex. That is a complex ion. And when you see H, you know it's acidic. When you see OH, you know it's basic. When you are seeing water crystallization, you know it's hydrated. Abi, that's all. So let's move on. Okay. Calculate the pH of a solution of 0.0001 mole per dm cube hydrochloric acid. What's hydrochloric acid? The formula is what? Thank you. I don't know why the option is like this, but let's calculate it. Hydrochloric acid is Cl. So for me, I will know that it only has one replaceable hydrogen ion, right? And so we are told to calculate the pH of solution of 0.0001 mole per dm cube. And we know pH is equals to minus log of hydrogen ion concentration. As this is 1, so we don't need to multiply this figure. So we just say minus log 0. How many zeros? 3 zeros. 1, 2, 3, 1. And you punch it out. There are 3 zeros. So let's punch it out. That should give us 4. Minus log. Don't forget your negative sign. That's 4. And that is 4. And so this is our answer. Okay. Let's 14.1. Which Which of the salts, okay? Which of the following salts would turn litmus red? A. Let me write it the way they wrote it. Let me abbreviate. Don't let me write the formula. Zinc chloride hydroxide. B. Sodium tetrahydroxysilicate 2. C. Potassium hydrogen tetraoxosulfate. That 4, 6, 6, 6. D. Sodium trioxocarbonate 4. Okay, so let's attempt this. Which of the following salts will turn litmus red? Which of the following salts will turn litmus red? What salt will turn litmus red? Acidic or basic? Acidic, sure. Acid turns blue litmus red. Base turns red litmus blue. So basically, they are asking us for the acidic salt. So from this, deduce the acidic salt. Option D. Try. See, let's explain why that is. Sodium trioxocarbonate. There's no hydrogen. There's no OH. So this should be a normal salt. So this is out of it. This is zinc chloride hydroxide. There is OH there, so that is basic, right? B. Sodium tetrahydrosilicate 2. This hydroxo is OH. Sodium tetrahydrosilicate 3. This hydroxo is already OH, so we know that is basic. Then we are left to see sodium hydrogen tetraoxo. I say when you see hydrogen there, just know that it's acidic salt. When you see hydroxo or hydroxide, they mean OH. So that is basic. And so the question says salt that turns litmus red. So first off, you need to know this table in order to know that it is acidic salt. Because you might be like, which one did we do the test here? Why are they asking us? Simple. If you know this table, you know what the salt will be, what salt you are told to pick out. It is acidic, basic, right? And so this is your answer. No stress. Just move on with life immediately. Okay. This question I said I mentioned earlier that I saw it in the first question, so let me just write it out. And the question is, oh, let me write this first. I just saw it now. The basicity of CH3COOH is A3, B4, C1, D2. This is organic, what's it called? Organic, right? Is that what I'm told to answer? Is that what I'm told to answer? Is that what I'm told to answer? Okay, yeah. This organic acid, acetic acid, that's C is 2. 2 is what? You don't know what I mean. Don't worry. This is ethanoic acid. You know it's ethanoic acid. Okay? That's what I say. C is 2. So 2C is what? So 2C is ether. 3 is propa. D is buta. Think fast. So this ethanoic acid, they are basically organic acid. So for organic acid, their basicity is 1. right? Don't say because the hydrogen here is 4, 3 here 1 here, then you pick 4. They are organic, so they are considered to be just one. There's only one of them that is replaceable, right? This one. This is the only one that is replaceable out of them. This carbon chain, the hydrogen here is not replaceable. It's only this hydrogen. So the answer is 1, right? So for organic is 1. But we are talking about H2SO4, H3, this one, they are inorganic. They are replaceable. This one has 2, right? So it is basic, but this is mono basic. Don't let me clean this back. Let me did you have it doing it? Okay, so the exact question I wanted to look at. Okay. The mathematical expression of pH is A log 10 1 over OH, B log OH minus, C log 10. I write it exactly the way the word is here. The way I'm seeing it here, that's the way I write it. Okay. D log H3O plus. If you're told to try, what would you pick? Which of them would you pick? Which of them would you pick? Which of them would you pick? Just pick one so that I can move on. Eh? B. Okay. We're told mathematical expression of pH. A. We know pH based on this class. I said log. This is what I gave you in class, right? And it can also be log of hydrogen, right? So it can be this. OH is OH. OH and pH are not the same thing, right? So it can be this, it can be this. So from the question, we'll cancel this, we cancel this. So I left with C and D. Don't forget this negative, right? Don't forget this negative. And based on indices, law of indices, log A to base 10 can also mean 1 over log A, right? And so if you're not giving this straight, it can also be 1 over. So because there is no negative sign here, it is not it. Rather, it is C. Are we together? I said pH is for hydrogen. So you can use any of these two. So OH is out of it because you're not told to calculate out of OH. So these two, they're already out of it. Right? And we have to expect this negative sign. And because we're expecting this negative sign, D is not the answer. And based on law of indices, negative can become 1 over log. Negative log can be 1 over that log. And so option C is our answer. Any question? If you have any question, you can please type it in the comment section. Right? Okay, so let's move on. I've said that. Oh, not. Okay, let me move on. 14, 20. Okay, I've done that. I've done that as well. 13, 21, 13, 21. Okay. Okay, this is a long one, but we'll do it. An insoluble salt can be prepared on my the way I'm just writing because I really want to attempt everything so that we can increase our confidence level in this exam. I'm sure as the exam approaches, as we can do countdown now, don't be scared. Don't be scared. Oh, is that okay? Okay. And insoluble salts. In this class, I made mention of soluble salts and insoluble salts, right? I said you classify salts based on their solubility, the ones that are soluble and the ones that are not soluble. And the way we prepare soluble salts are different from the way we prepare insoluble salts. And so, how do we prepare insoluble salts? And insoluble salt can be prepared by A, the action of dilute acid on an insoluble base. B, the reaction of metal with an acid. C, the reaction of trioxocarbonate 4 with an acid. D, double decomposition. In this class, I made mention of 3 ways in which you can prepare soluble salt, which is option A, option B, and option C, A, B, C. And I made mention of one for insoluble salt, which is double decomposition. So you can prepare insoluble salt by using double decomposition. Okay, let's move on. Let's 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 move on. Let's move on. 12 something. 12 something. Okay. 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 I just say now. I just okay. I just okay. Yes. 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 The number of hydrozonium ions produced by one molecule of an acid in aqueous solution is its A, basicity, B, acid strength, C, pH, D, concentration. Okay, let's take that question together. The number of hydrozonium ion is H3O plus. So, so that's why we could use this and this, right? So the number of hydrozonium ion produced by one molecule of an acid in aqueous solution is its A, basicity, C, acid strength. No, A, basicity, B, acid strength, C, pH, D, concentration. In this class, I made mention of basicity of an acid, right? And I said it's the number of replaceable hydrogen ion in one molecule of an acid, right? And you can use hydrogen ion and hydrozonium interchangeably. And so the answer is basicity. Are we good? Okay. So let's move on. I like our pace, so we can do better. 1321. Okay, I've done that. I just did that now. of constitution. Okay, 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 okay. Okay. A major factor considered in selecting a suitable method for preparing a simple salt is its A, crystalline form, B, melting point, C, reactivity with dilute acid, D, solubility in water. Look up. A major factor considered in selecting a suitable method for preparing a simple salt is its A, crystalline form, B, melting point, C, reactivity with dilute acid, D, solubility in water. What do you think it should be or it can be? I just read the question now. Look at it very well. A major factor considered in selecting a suitable method for preparing a simple salt. A, crystalline form, B, melting point, C, reactivity with dilute acid, D, solubility in water. What do you think? You think D? Okay. In this class, I made mention of salt. I talked about soluble and insoluble. And I also mentioned that the way you prepare it differ. And the question here says, suitable method for preparing, right? And it is based on their solubility, right? It's based on their solubility. That's why we have insoluble that would have to undergo double decomposition, whereas soluble can undergo reaction of acid with metal, with carbonate, or with insoluble or with alkaline, basically. Okay. So, 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 so. I've done that as well. 11, 9. Okay. I'm not very sure this question is under this topic, right? But it's a question I want us to think about and answer. So you're answering it together. I'm not the one doing the. I just stumbled on it while I was checking through the first question and I saw it. I was like, oh, this is in the first question is worth considering. And so I decided to include it. So another topic can be the domain knowledge. But knowledge of this would help, especially when considering when doing pH and knowing the basicity, if it is mono and all of that. So that was what came to my mind while I was going through it before coming for class. Okay, the board, please. How many cations will be produced from a solution of potassium tetraoxosulfate 6? What is potassium tetraoxosulfate 6? Are you looking at me? What's the chemical formula for potassium? Okay. What's the chemical formula of tetraoxosulfate 6? What's the chemical formula of tetraoxosulfate 6? Say it out now. SO4. It has a charge. What did they say? SO4. What is the value? They say 2 minus, right? Potassium is in what group? Group 1, group 2, group 13, group 14, group 17. Potassium. Okay? 19 elements. Is in what group? Is in group 1. Right? Is in group 1. This will be positive. And while I was explaining the other time that the charge will, so when you cross like this, in this class, we've spoken about chemical formula, writing of chemical formula, right? And writing their names. If you are not still very confident in that aspect, please check out the video in the file. I'm sure you have access to the videos, and so just go through it again. And so when I write this, I write it as K2SO4 because this will take the charge of this, and this will take the charge of this. This is one I don't need to write it, and I don't write this sign. So this is potassium tetraoxosulfate 6. And here I'm being asked how many cations will be produced from a solution of potassium tetraoxosulfate 6. We know this is the cation, this is the anion, right? Potassium is the cation, tetraoxosulfate 6 is the anion. And so from this formula, how many cations will be produced? Definitely 2. So for you to answer this question, you actually need to know the chemical formula. And so it's just as easy as that. If I know that potassium tetraoxosulfate 6 acid is K2SO4, I'll know that the number of cation is, and K is the cation because K is in group 1. And so SO4, 2 minus. From the minus you hear, is an anion. And so we know the answer is 2. Any confusion here? Are you sure? Should I take it again? No. All right. This is a good, let me just check the last one, 11, 19, 10, 20, 11, 19. Okay, 10, 20. What does it? Okay, this basically, let me read it out. The color of methyl orange in alkaline medium. The color of methyl orange in alkaline medium is A, orange, B, red, C, yellow, D, pink. The color of methyl orange in alkaline medium is what? I didn't guess work. I said I didn't guess work. I didn't guess work. You're sure? Okay. Unveil. Are you correct? Please, let's learn this table. Let's learn this table. You see that we've already seen like 3 questions under that. Please let's take our time to consider this table. The question is, what's the color of methyl orange in alkaline medium? The color of methyl orange in alkaline medium is yellow. The color of methyl orange in acidic medium is red. The color of litmus paper in, sorry about that. The color of litmus paper in acidic medium is red. So just know that for acidic medium, litmus paper and methyl orange, red, while that of phenolphthalein is colorless. Whereas basic medium, it is yellow and blue and pink. So its basic medium have variety of colors, whereas for acidic medium is just red, except phenolphthalein that is colorless. I'm sure we've considered handful more than 10 questions, and with this we'll draw the curtains this class. Thank you very much. Thank you. And please make great use of your time. Consider more past questions, attempt more questions, read your book as well, and You're good to go. I'm certain we've learned a lot from today's class. See you in the next class. Bye. Oh my.